The last catch is that we need a really good random number generator. We need one that fits the definition of a cryptographically secure pseudo-random number generator, or CSPRNG. A cryptographically secure random number generator will have usual random number generator properties, like you can't just predict the next output from looking at previous outputs. You have to know the state inside in the random number generator. And the kind of numbers that come out need to pass various statistical tests, like there's just as many even ones as odds, or the third bit is set as often as not, or the numbers are above the midpoint as often as they are below the midpoint, and so on. But a cryptographically secure random number generator has an extra property, which is even if you look inside at the state of the random number generator, you can't figure out what came before it. You can figure out what comes after, because you can keep running the pseudo-random number generator, but you can't work your way backwards. And that turns out to be an important property for ensuring a secure communication. Let's talk more about the inside of a random number generator. I'm going to draw the inside state of a random number generator as these gray boxes. Let's suppose that every time we call random, we want to get m bits of information. So if we're asking for a random number between 0 and 255, that would be 8 bits of information. And let's also say that we're going to get c samples from this random number generator. That is, we're going to call random c times. Overall, then, that means we're asking for m times c bits. What are all the possible sequences that we could get by sampling the random number generator this way? Well, it's going to be 2 to the c times m, right? Because each of those bits is 0, 0 to 1, and so that's 2 to the c times m. Now, to get these different m's out, there must be some state inside of the random number function, because if it didn't have any state, it would give you the same number every time. And let's say that there are n bits inside that gray box. That's how much state the random number generator is willing to keep. Every time you call random, some of those bits need to change. That is, you need to go from some state to a different state. If you didn't, then the next time you call random, you would have to give the same result back, because you wouldn't have recorded anything differently. But since the state does change, then you can get a different result every time you call random. How many different states can this random number generator be in? It's got n bits of information, so there are only 2 to the n possible states in the random number generator. So what this means is you need to pick a random number generator with enough state that you can get as many different random numbers as you want. If c times m is a lot bigger than n, that means you're going to end up getting the same sequence of random numbers very often, and that's not random at all. So that's one concern for a random number generator. Let's use a different picture to look at another concern. Here I'm drawing all the states of a pseudo-random number generator. So every gray box is a different state, and every possible state is represented in my picture. The blue dot is the current state, and when we ask for a new random number, then it must go deterministically to some other box in this space. After all, it's not really a random number generator, it's a pseudo-random number generator that behaves in a deterministic way. And from that new box, when I get another number, it'll go deterministically to another box, and so on. Because there are only so many boxes, that eventually we must get back to the same place if we ask for random numbers long enough. So what we want out of a good random number generator is that this cycle is as large as possible. We can also talk about the distinction for a cryptographically secure random number generator in this picture. That's going to be one where, after you took a step in the box, you cannot figure out where you came from. You cannot go backwards. All you can do is keep going forwards, hopefully in a very long cycle. We talked about the seeds that you give to a random number generator. Often, the interface for providing a seed lets you provide a number that is smaller than the state of a random number generator. That is, the seed for an n-bit random number generator is sometimes less than n bits. And so all of the possible starting states may be fewer than all possible states. So that's another thing to consider, and generally you want an interface that lets you get to a large number of starting states to get a large number of different sequences.